Hello guys, my name is Alex, and this is another Alias Autostudio modeling tutorial. Today we will focus on creating this boxy curved shape, forcing the transitional surfaces. As always, we will be working under the tight tolerances and striving for maximum accuracy and quality. Content will be split into parts. The first one will be about building the curved cap, and the second and the last one is finishing the model. Content aimed for the beginners, but not for the first-timers. General understanding of the software is required. As always, it will be a long one, so buckle up and let's get started. Okay guys, so we are in Alias, and before we start, as usual, let us check construction tolerances. So I already opened them for you, here they are. So if you really want to follow along, just pause the video and copy the same parameters, especially the rational flags, these ones. And if you don't know what they are, in the previous tutorial called Roll the Dice, in the beginning of the first lesson, I made a quick explanation. So you can check it out if you don't know. So, alright, these out of the way, let me remove it. And just store it somewhere here. Let's get to the actual modeling. So I will start by defining proportions using the square tool. And before that, I will just toggle my perspective to orthographic, like that. So if you don't know where the toggle perspective located, it's in the view. Where is it? Yeah, toggle perspective, this one. Alright, and I get a question about where the key point curve tools are. They are in the curves, in these elements. If I click on it, you will see here they are. Alright, so I switch to the top view, zoom in, and I will create the rectangle. I just click and click, and in the attributes panel, in the information window, it's in the Windows information window here. I will type my width. I say 140, and height will be 70, like this. Right. Now, let me snap it to the center. I'm using Alt to snap. And another question I got is how I snap to the CVs. So you can't snap to the CVs when they are not visible. But if you show them, activate them, then you just hold Control. Like that, and this is how you snap it. So what I did is I snapped 1 degree curve along the y-axis here inside of my rectangle, and this curve will define the character of my cap. So what I'm gonna do is I'll bring more degrees using Alt-D. Rebuild parent is this menu basically, and Alt-D I assume is a universal hotkey. So now I will select the CVs and center the pivot using center pivot. Select both of them again and scale them to 2.2. I will try to be as parametric as I can, so it'll be easier for you to follow. So now let's pick the CVs and then push them up to 14, like this. Okay, so we defined one basically direction of our cap. Now we need to define another one. To do that, I will create the guide curve. And let me just show the CVs, snap it, and the actual curve I will be using to create the transition. So it's a 1 degree curve, obviously, so we need to bring more degrees. And what I do is I'll bring 4 degrees here. Why 4? Well, because I will be aligning as a G3, and for G3, I need 3 CVs. So except the, let me show you. Just click using my align tool. It's right here, and just click again. So as you can see, 1, 2, 3 points are in use, as well as one as a start and another one as an end. So we actually aligned it, and I would like to just pause here a bit and just describe this curve, like why we aligned it as a G3 and what is G3. So basically, if I will show you the curvature comp using curvature tool, this one, that's how it looks like. So you can see these kind of like the acceleration curve. This is an acceleration curve, and it shows me the gradual acceleration from absolute flatness to kind of like a curvature. So it just curves down, its acceleration is growing and growing and growing, and it just grows very smoothly. So this smooth transition called a lead in. So I'm leading this curve into this curve. And if there is a misconception that for lead-ins you need to have a G-free curvature, that the G-free curvature is the curvature with lead-in. Well, it's not true. You can do the lead-ins using G2 curvatures, no problem. Let me illustrate it. So I will use my Curve Edit tool to go to the history, and I will change my align options to G2, and I will remove one of the degrees because this degree is not in use anymore. So let's remove it. Okay, so as you can see, there is no lead-in at this point, just like linear acceleration, if you will, at this point at least. So what I'm going to do is I'll just spread them apart a little bit, just push them away. And as you can see now, I have a lead-in as well. So why I'm using G-free here? Well, I'm using G-free not because it's G-free, oh my god. I'm using G-free because I need more controls to define this part of the curve, because I really want it to be closer to this curve. They will never be exact because, well, they actually have a different length, but I'll just do it somewhat similar, and for that I need additional point. So let me just revert everything and just do it again. So align options, G-free, edge, click and click. All right. So as you can see, even with the G-free curves, the character of the lines are really different. And this will do. If this is the surface you want, you can just proceed like this. But I would like to make them a little bit more equal. So what I'm going to do is I'll duplicate this curve, Ctrl-C, Ctrl-V, push it away, and then I will use Detach tool, and using Ctrl-Alt, I will just snap to these blue marker, release and hit spacebar. So now I basically detached that. Now this is two different surfaces. And by the way, if these elements, you don't see them, and I actually explained it, I guess, in the previous videos, then it's in these menu, there is a small triangle. If you click on it, there is like curve snap options, snap divisions 2. So you can say it will be 5, 55, the way you want. It basically divides it the way you want. Very helpful tool. Okay, option better say. Now let's pick this curve, and I will rotate it on -90 degrees, and then using the set pivot tool, I will snap it using Control to this edge, and then I will move it to the end of my newly built curve, this one. Right, so why I did that? Now it's basically a guide for me, and now I can just go and use the Curve Edit again, go to this my align tool, and just try to kind of align it a little bit better the way I want. As you can see, the character is different, but I need only kind of this part to be similar. So, and as I said, I will try to be parametric. So here's parameters for these this curve for you if you really want to follow closely. So in the align options, in the tangent and curvature CV adjustments, you basically have all the numerics for the positions of these points. And what I'm going to do is I will type in the tangent scale 2.7. In curvature scale, I will type 4.4. 4.4, come on. And in the G-free scale, I will type 6.2, like that. All right, close. Now let's delete it. We don't need that anymore. And actually, what I'm going to do next is I'll create the new layer. I will call it temp, like a temporary layer. And I'll select everything and just paste it in. All right. Now I need to create the surface. So we have all the necessary parts to create our surface. So let's do that. I will use Rail tool, this one, and with the same option. So it will be positional. The sweep mode will be parallel. There will be no explicit control. I will click on this curve and then on this one. So this will be the generation and this will be rail. And I need to mention that if your rail and generation are not equal, so basically the rail you build is not symmetrical in all the axes, then the order matters. Like, let me repeat, but now take this one and then this one. So this is the rail, this is generation, and this is the rail. As you can see, their form is quite different. So it's quite different because now we sweep basically this curve along this rail. So I'm not really happy with this alignment, and the actual appearance is the same, but the surface structure is not ideal. So I basically revert it and do it the proper way again, like this. Right, and let me actually show you the surface. So let me shade it. So it's actually great. So it's perfect. Like, Alias did a great job, and it just created a good transition for us using our curves. But this is not the surface I really wanted. So if you really want to get a natural transition, as natural as it can be, then this is a great surface and you don't need to modify it, right? So you just, I don't know, create the curve somewhere. Let me just quickly demonstrate, right? Create the curve. Let me push it away. Let's project that. It's on Y like this, maybe too much. Like this, and I can just, you know, trim that and push it into the other direction, and basically you have your, well, caps on the both sides. You can create the wall. Like, this one is a really dirty edge, so I will build from the trimmed edge, which is a big no-no, but just for demonstration purposes. Like, there's a lot of spans, it's not even positional, but it doesn't really matter. So you get the point. So if you really want to get the natural transition, well, this is the great way to do that. But I don't want a natural transition. I want my personal form, and I don't want it to have this constant curvature. So what I want to do is I want to make them straight and then create a piece where it actually will be transition. So this straight, this straight. Right, let me delete this. Let me retrim that. Let me delete this current surface and delete this line. So we get back. Okay, so how am I going to do that? So as you can see, this surface have a pretty substantial acceleration to the ends, and this is a bad thing. So first things first, which I want to do is I would like to realign it, basically make that straight, but preserve this acceleration. So how am I going to do that? At least like preserve this acceleration for the top part. So what I'm going to do is I will isolate it. And I will use my patch precision tool. So basically, I will hit tab and type 7. Okay. So now I have isopams on my surface. Actually 7 by 7, and they give me the good guides for trim converting this surface. So what I'm gonna do next is I will insert using my insert tool, and I will just drag, and using Ctrl Alt I just snap. So first of all, I will snap to the center, then I will snap here. Yeah, I think this will do. And then another one I will snap here. Okay, so this part I don't need, so I will use this tool, the trim tool. Here it is. I will click and accept, and then click again, and basically trimmed it. Right, and now I have what I will have two pieces, this one, and then everything else I will just remove. So let me use trim convert tool and convert them as a separate surfaces using our boundaries which we crafted. So this is one, second one. Let's pick both of them and assign it into the kind of like a default layer. Let's hide the temporary. Okay, so this is what we get. So if we'll check it, it's all good and nice, but even though that we have the hole, which we will use to fill our cells, these surfaces are still inherited their structure and their character from the original one. And once again, this is like too much. We need to make it straight, basically. Right, so how am I gonna do that? Oh, it's actually very simple. So what I will do is I will use my plane, standard plane, scale it a little bit, and then let me remove the shading. What I'm gonna do is I will use my align tool again. I will project the G1 on the using project on Z. So I'll constrain it as in a Z direction, and click again. So okay, now this one is straight. The problem still persists though, because these row CVs, let me show it to you, it still bends, it still inherits the original positions. And even though it's good for these ones, these two, it's not good for this one. It's just too much. So what I'm gonna do instead is I will use my query edit to open up this tool again, and it's history. And in the alignment type, I will check blending, and blending options, I just slide it until I'll hit 1. So now it's the first row, and the blend factor I'll leave as is, so basically to 0, like that. So actually, so just for the demonstration purposes for you to see, actually what we have right now is we changed these kind of like tangent row, if you will. This one is a tangent row, and it's just now absolutely straight. It's exactly what I want. So the character here and the placement of the CVs is not great. So what I will do probably is I will just go to the history again and push the CV rows even further. It will disconnect from the surface, and I know that, but that's not a big deal. Right now what I want to do is that it will be straight and it will be accurate. Now let me repeat the steps on this one, but this one as a main surface, I will not be blending all the way to the end, because otherwise I will just do the straight surface. I don't want that. So instead I will project it as Z using blending, but only one. Alright, so as you can see, these row CVs and these rows of CVs, as well as the bottom part, are already aligned the way I want. So the top, this one was straightened, and as a result it just lost its connection. Let me show you the surfaces again. But this one still preserve the original form, and this is really important because this part really creates the character of the whole construction. So what I'm going to do next is I will realign this, and to do that I need to delete the history, and then I will realign it. So how will be realigning it to this? Well, first of all, once again I'm using Align tool, but instead of aligning it to the edge partially like this, you know what's the problem with this is a G2, is that it just skew everything based on the edge, you know, like this. So and the CVs just go south again. Oh yeah, it's just because extra CV, like here, you know, it just bends. It's not perfect. And to demonstrate that, let me just delete this surface. Let's delete these ones. I will create a couple of straight lines here and here. And if you look closer, even though that this one is straight, this one bends. So that's because when I align to the edge, Alias automatically tries to align it to the surface with its own curvature constraints and curvature mechanics or parameters, math, if you will. So what I would like to do, and what I would tell the Alias is that, hey, align it to the curvature, but don't mess with the position of my CVs in any direction except the normal direction. So what I'm gonna do is I will, in the edge, instead of the edge, I click vector, and in the vector there's a Z direction like this. So if now I check it again, you will see that it's just now perfectly matching. So what we did is we constrained the Alias of moving these CVs. We asked them to move to achieve curvature only on the Z direction. That is exactly what it did. Alright, that's much better. This will do. So don't forget. And actually, position influence, I assume, will not really matter here at all. Yeah, it doesn't. Just, oh no, actually a little bit. So let me check it by create another two lines and figure it out. Alright, so yeah, position influence should be set to 1. Okay, cool. Now let me remove all of this and delete the history. So it's curvature now, and we have the edge, and we have the straight, we have the the proper square here. We have a straight edges, all great. Now we need to figure out how we will build this transition. So if you will try to build it with a single surface, basically the curve here, and then just this triangle, you probably know that it will not be a great idea, because you will have a converging points here. So these points will come to the one single point, and you will have a big problems with that. You will not be able to align it as a curvature, and you will have a dimple here. It just will be a horrible solution. So instead, we will build two surfaces so that the main transition surface will be actually a square. To do that, I need to create a couple of guidelines for us. So I will click on the surfaces. So basically, I'll pick the surfaces. I click on the patch precision tool and type 5. All right, like this. Cool. So now let me project or insert, let me just insert a couple of curves to my isopams, and actually do one here. It will help my rail tool. Now what I'm gonna do is I will basically trim that. I didn't trim convert, they still exist. And I will go to my rail tool and create this patch. It's a perfect situation to use the rail tool. So in the monorail, I need to get some changes though. So first of all, the continuity will be curvature, and I will turn on explicit control, and I will type 3 by 3. I will tell you later why it is 3 by 3. For now, it's just 3 by 3. So click and click. And if you followed along with me and you have the same proportions, then it will be curvature like that. All right. Now what I need to do is I need to delete the history. I don't want to mess with it anymore, and I will just retrim it like this. Okay. Now, let me actually delete this guides, and this one I will save. I will save it for the demonstration purposes, so just let it be here. Let me just actually even trim it. So you shouldn't do it. It's just to illustrate a couple important things a little bit later. So now we have a square, and you probably see where it's going, right? So now I will build two transitions, one here, one here. I'll build the curves, and then I will create a square patch, and then I will project one of the sides on this newly created rail surface. So to do to create the curves, we actually have a couple options. So we can use the standard curves, like the general ones, you know, like you go here, you bring more degrees, so I'll bring 5 degrees because I would like it to be curvature here, and then align it, right? Like align here, Oh, that's actually because I have a extra CV roll and here off. Okay, you align that, then you just go here and manually kind of like pick the proper parameters, and then you do the same for the bottom part. It's a pretty inconsistent, and if you really want to follow along, you need to mess up with all these numerics and stuff. So instead of doing this, there is another great tool which is called a blend tool. So let me open the blend curve toolbox. Here it is, and if you're wondering, it's in the palette in the same place where the key point curve tool is. It's this one. So you click and you will have the same elements. So the blend curve is great, and it just what's good about it is that I'm using Ctrl-Alt, snapping it, using the edit tool. It's hotkey for me, of course. I can align it properly, and then it's just equal from both sides. So it just have the same kind of parameters for both of them. If you open the options here, you will see that there is a node spacing. In mine is uniform, and basically I know that they are equal in a way. So that means that if I will scale it, it will scale proportionally. You see, there is no numerics, nothing. And I still can be numerical, and I can just type like, I don't know, 2, for example, and it just does the job. I don't really want this specifically, but yeah. So it's a great way to do the transitions, but there is a catch. And not a lot of people, well, actually the newbies didn't really know this, but blend tools aligns differently than the actual curves. So when you have the actual curve and you align it to this edge using degrees, it will align using one method, one mathematical algorithm, if you will. And if you're using blend tools use a different algorithm by default. So it can work the same as a curve and it cannot. And by default, it works differently. So let me illustrate it on these examples. So let me put my rail into the temporary folder for now. And what I'm going to do is I will create two straight lines. Remember, we aligned that it's absolutely straight. So they're basically curvature here, basically in line. So now if I will use my blend tool, create the blend like this, I will align it using edit tool, this one basically. So basically to do that you actually need to pick them. So you pick the these edges using edit with shift, and now you can kind of like, there is like this gizmo, right? And you can change the direction, which I will do. So I'll change the direction. This is the wrong one. Okay, this is the proper one. And then I will do the same for this one. I just click on it and click again. So if I will open up my CV structure and look at the top, from the top, zoom in, you will see that this CV is not in line with this one. It's not collinear, even though that the lines, these ones, they are actually straight. Well, what's going on? Why it's happening? Well, it's very kind of minor change, right? But it really depends on the model. If the model is big, the transition is big, the deviation will be big. So and it just so basically it does it purposely, basically, because this method helps a lot to create a proper structure. But at the same time, it actually, in our example, it actually works against us, because I really want to work collinearly, and I really want that my edge will be straight. I have a straight lines here, I have a straight lines here. I just want it to be bold, straight edge, if you will. It should have a beautiful curvature, but I would like it to be straightened out. So in the blend curve tools here, there is two basically, it's not an instruments, but like a functions, I guess. One of them called geometry and the other one called parametric. So if you hover it, you will see constraint curvature type tool. So basically, by default, the standard curves works with a parametric curvature and method, and the blend curve with the geometric curvature method. So let me illustrate. I will just pick my curves, and in the parameters opened up, I click on parametric. Watch on this deviation. Bam, it's gone. Now it's straight. But because by default it's geometric like this. So what geometric does actually, and what's the difference? So parametric aligns to the isoparametric, to the isopams basically. It aligns to the isopams on the surface, and the isopams are actually parametric curvature of the surface. You know that lines which we built in this tool, you know what it is? It's isopams. Why it's isopams? Because they are isoparametric. So and that's why when we aligning these one to them, it's skewed, because instead of aligning actually to them, which it looks like it does, in reality, what it does is that it creates a surface relative, placed normally to these ones. So basically, imagine that there is the surface, it intersects it, and these blend tool aligns tangentially to the line of intersection, not to this line in reality. That's why it's skewed a little bit. You know, actually, I think that, let me just pick it, and let's just hover it. Come on. Yeah, there is a help here. Okay, that's great. You know, Alias have a great documentation, by the way. So let me just open it for you. Yeah, that's what I'm talking about. So the two types So this is the geometric curvature. This is how I describe. This is the normal surface, and this is the tangent line which the blend curve actually aligned to. And this is the parametric, kind of the basic one. We aligned that actually to the as a parametric line of the surface. I mean, these ones, right? So you need to keep it in mind. Now you know. So if something is just skewed, now you know what the problem is. All right. So let me just delete this. And let me actually quickly rebuild the surface just for demonstration purposes. So click. I'm using edit tool and realign it proper way, like this. Right, now I will pick them all again and I will check parametric like this. All right, so now you know this stuff is parametric. Cool. Now let's repeat the steps for the bottom part. So I'll basically do the same thing, realign here like this. All right, and pick it again, and once again it should be parametric. By the way, when we're talking about these straight lines, it actually doesn't matter. So it can be geometric, can be parametric, it will be straight because isopams are straight as well, and the surface, if we will put it along the normal, still will be straight and it will align up. But this one is curvature, so yeah, no way. All right, so let me check using curvature comps, my curvature tool, and as you can see, this transition surfaces or curvature, sorry, it's not that great. It doesn't have a lead-in. I want a lead-in because I want a gradual lead into the surfaces and beautiful highlights. So this is a 5-degree curves, which means they're not G-free. But as I mentioned in the example of the curve which we built before, this one, you don't actually need it. And in this situation, as this curve is small, and it will be even smaller later, because I will be offsetting it a little bit later, I don't have much room. So instead what I'm gonna do is I will pick these endpoints, I'll click on this rectangle, I'll hit tab, and I will just squash it, basically create the leading by just moving CVs. So what I'm gonna do is I will type 1.3, enter, and you can see that it's immediately, even though it's just 5 degrees, we will have a lead-in. It's not a crazy smooth one, but it's good enough. So this will do, definitely. All right, so now let me go back to the temp. I will pick my surface and go back, push it back. Okay, so now we are ready to create our patch, the 4-sided patch, this one. This side, and this side. And once again, there is two ways how you can do it. You can use rail, you can use square. I will use square in this situation because I want them to be just in the neutral positions, and you will know why in a bit. So let me open up my square tool, this one, and let me just, well, square it basically like this. All right. So at this point, what you probably will do is you will like, oh, okay, I will just do it collinearly, no problem. There is a collinear options, and I will just say that everything will be curvature, and I will just set collinear, and bam, we done. And as we have the proper structure here, the proper surfaces, these edges will be absolutely collinear. And if you look into, oh, sorry, if I will just drag the line, you will see that, yeah, well, it's actually collinear. Great, this is a great result, isn't it? Well, not quite. You see, the square tool, it creates these blends between the boundaries, and you even have a parameter for that, 1, 3, 2, 4. You can't get away with them in this situation. Why? Well, first of all, it's good that it bends. In a lot of other situations, it's great. But in this example, it's actually will work against us. It makes our life harder, and what's more importantly, it's kind of like bends our highlights in the direction we don't really want. So if I look at the zebra stripes, it's kind of like if you look closer at the edges, you will see that it just bends, and then it bends again, and then it bends again. Just too many bends. It's not supposed to do that. And the reason why it's happening is because of the bands of the CVs. So we need to straighten it up. Let me go back. So we are in the active history of the square, and now what we can do technically, which is the wrong solution by the way, is just to straighten the holes based on the view. So we just can go to the top, pick our planarize hole tool, and here I will, instead of a best fit, I will change it to view based, all U, and just click on it. As you can see, it destroys the history. It aligned it, yes, but it's angled it, just skew it a little bit, as if this was a geometric curvature instead of a parametric curvature. And once again, this is not a bad thing. It's actually, for a lot of situations, the great structure. But first, we lost history, and second, it just still bends. I prefer, in this situation, make them still straight. So what can I do now that the history is gone? This is like the destroyed surface. So of course I can try to manually align everything and etc. But it's just a waste of time. So instead, I will just delete it and create quickly another square. This one though, I need to be sure that it's positional, and only on these sides the free should be free. I don't want to mess with it at this point. Alright, so we have a non-collinear structure. And just a quick note that you can create the same model using without collinearity, absolutely without collinearity. It probably will force you to move a little bit more like CVs around, basically CV massaging a little bit more intensive, maybe additional degree will be needed, but the overall quality will be good. So it's not really a necessity. So yeah, but I still want to make them straight because I think it serves this structure really well. So how am I gonna do that? First, as we can't straighten the holes because it will destroy the history, I didn't realign, I will just delete the history. I don't need that. So it's just positional. Now, remember I trimmed the surface and I said that it's for the demonstration purposes. Well, that's exactly what I showed to demonstrate. So I need to realign it, right? And I would like to realign it with collinearity. So our align tool, this one, aligns collinearly, no problem. But if I will really try to do that, and I'll just do it right now, and I will check it, look at this style, look what's happened. So it's all proper. So once again, it should be skewed. It's not the edge. We already defined our edges the way we want, but it's not collinear. Well, why? Right? Like what the hell is going on? Why it's not collinear? Why it doesn't work collinearly? Well, it doesn't matter what I do. I just don't want to do that. Well, I don't want to do it because the surface is trimmed. It's not trim converted. It's trimmed. So if I will just remove it and I will retrim, so I basically canceled it, and then I will retrim it again. Let me just demonstrate. So it's a partial alignment. Bam! Oh, look at that. Now it's all aligned and it's all it's all collinear, but not quite. So as you can see, it's still trying to bend this thing just a little bit. You see, just a tiny bit is just still kind of skewing him, right? So what is the proper way of doing it though, and why I go for the alignment tool, and what's the benefit of even using alignment tool in this situation? Well, first of all, what's good about that is when the align option have a really good connection with the planarizing holes, because when I will planarize it, it will not destroy my history, and after planarize, it will realign it again, which is a huge benefit for align tool. That's why we ditched the alignment in the square tool. But the align itself, this tool specifically, this one, doesn't really align using parametric alignments as a collinearity, this one, and it doesn't work when the surface is trimmed. In this situation, it's not a big deal that the surface is trimmed, because once again, it's just very artificial trim. I don't really need it. But there is a lot of situations in practice where you trim the surface multiple times, and then just to align something, you need to retrim it all the way to the base, and there can be 30 trims, and then you need to trim it again. You know, it's just a very cumbersome process. So there is a solution, though, where we can solve this problem with the collinearity using the parametric collinearity instead of geometrical one, the alignment, sorry, in collinearity, and work with the trim surface. So let me revert and let me trim again, just for the demonstration purposes. So this is our square as it was. And now, instead of using Align tool, I will use Align 08 tool, this one. So there's two alignments tools in the Alias, if you didn't know. So the Align 2008 or 08 is an old tool. As you can see, there is even the orange like explanation mark. Yeah, so it's like, hey, look at this. This is an old tool. It basically tells you that this tool is obsolete and it's surpassed in any way by the new Align tool. And when I say the new, it's not actually that new. It's like for a decade already, but the 2008 is even older. So, as you can see, it still exists in Alias. Well, why? Well, because it have a couple of features which are extremely useful, and professionals use Align tool till this day really extensively. They actually use both because both of them good and they are slightly different. So, using Align 2008, we actually can align it to the complete collinearity to the surface using parametric alignment. And we can do it with the trim surface. So watch. In the modify, I will say first, so this is the first surface, this is the second. In the continuity, it will be curvature, and in alignment type, it will be collinear. So now I will go to the partial alignment here, open it up, and instead of off, I will check T join. So basically, it's a partial alignment, that's what it is. And now, when I will click on my surface, and actually let's use continuity check and click it again, bam, it's immediately curvature. And if I will check the structure or look at the surfaces, you will see that, yeah, it's actually really, really, really high quality, and it's just really collinear, just straight. Exactly what we want. So now let's repeat the step on the other side. Let's do this one and the second one. All right, and remember all this drama with the planarizing holes in the square, that it just destroys the history, and basically I can't really make them square and collinear, or make them straight and collinear at the same time. Well, when both Align tools, the old one, the new one, actually work with planarized hole really well, it just saves the history and realigns itself. So basically, I open up Hole Planarize again, view-based, all U, and I will click, and it tries to straighten it. But you see, it straightens and realigns. And it's not quite straightened it completely. So what I'm going to do is I'll just click again, and again, and again, and it just do all of them at the same time. And I'll just click a couple of times. Every single time it realigns itself. So I'm sure that it's collinear and it's straight. So it's not moving anymore. So yeah, this is the straight lines, the straight holes, and they are collinear. Perfect. This is the great surface actually, and I'm pretty happy with that. And yeah, I forgot to show you why I'm even straightening them. So let me, don't delete your surface, it's already great if you already did it. So let me just quickly redo the same as I did before. So let me delete the surface. Let me, sorry for this inconvenience, I forgot to show you. So it's important. So let me realign it once, realign it twice. Okay, so if I will check the my evaluation diagnostic shading, you will see that it just bends. I already showed it before. So now, when I will planarize the hole, so once again, I am under the history of Align tool, and I will click, doesn't matter where, and click again, and click again. You see what's going on? Let me just click a couple times. Okay, that's done. You can see how it changes the character of this transition and the highlights. They're not bending this kind of like back and forth. It's just really smooth now. Okay, so let's go back. Now what I'm gonna do is I will delete the history now. I don't need it anymore. So I will delete. And now you see, the only thing left, actually, is just to project it on the surface. And as you can see, we can't be collinear with this because the direction is completely different, right? Well, that's not the problem. In this connection, we will not be collinear. But what I want is I would like to preserve the structure of the surface which we built, spent so much time on it, and I don't want that after alignment, all of this is just wobble again. So, first, I need to extend it a little bit because, as you can see, they're just matching here, and when I will project, most likely I will have problems and the gaps after the projection because I will be projecting it along the normals and they just do not connect. So I need to overlap it a little bit. So what I'm going to do is I will use Extend tool with Extrapolate and Merge at the same time. Let me just delete the history. I deleted it already. So I'll click on it. I click on my square. Oh, Extend once again. Click on this arrow, hit Tab, and type well, I don't know, let's type 1.5. Okay, so you shouldn't go overboard because if you kind of extend it too much, then most likely you will lose the continuity and it will force you to realign it again. Well, you don't want to do that again. We're try to be efficient. So, okay, so now when I will project, guaranteed I will hit my surface, right? So now, the last thing what you need to do is just to actually project it. And now, as you probably remember, I said that you need to build a surface 3 by 3. Well, why 3 by 3? Well, now I can explain. You see, these two edges aligned as a curvature, which means that these rows are in use. All of the CVs are in use. They're in use to align to the curvature. This one is free, which means that I can adjust it along the normals to basically match these two surfaces together better. And if instead of a 3 by 3, I will have 4 by 5, 5 by 5, 10 by 10, doesn't really matter, okay, you can't do 10 by 10, okay, 9 by 9, then what it leads to is that it just, the actual process of aligning will be extremely more challenging because you need to align not only one CV, but a lot of CVs, and you're not a machine, so to really create the beautiful highlight with no dimples and stuff, well, you will kill yourself in the process. It will be quite challenging. Like, if it's just like, I don't know, like 4 by 4, it's manageable, but, you know, if you really want to have a clean surface, the accurate surface, you need to strive for the minimum amount of CVs, and this one is ideal for the situation like that. Now, as you can see, it was aligned as 3 by 3 really easily to this part. But if this square was bigger, then definitely, you will not be able to align it with this amount of CVs. So when I crafted this model for the first time for this lesson, I spent some time, I think like 5 or 10 minutes, to actually play with these ratio, with these isopams, like 5 isopams, 4 isopams, 5 by 4, 4 by 3, and just quickly rebuilding the rail and looking like what is the deviation. And basically this is the sweet spot. So it should be the specific size. It should be too small and it shouldn't be too big. It should be exactly the size that the 3 by 3 will actually give you the curvature. The moment it happened, that's it. You hit the sweet spot. Alright, so these out of the way, let's just actually finish this edge. And what the hell is this? Let me delete it. Okay, so what I'm gonna do is I will show both of the CV structure, and now I will use Align tool, the standard Align tool this time. I'll click on Project. On the normals, we'll be projecting along the normals. The position of the lens will set to 0 because, once again, they're not collinear, the structure is completely different. I don't want that the Alias will span, like, just kind of destroy my aligned CVs, right? And now I will just click and click again. Alright, so you're probably looking at this and like, holy shit, we spent so much time and you bring us garbage. Well, no, actually we're almost done. So it looks very scary, but we build a really high quality surfaces. We align these edges really perfectly, so everything is okay. The only thing which is missing is the actual final alignment or position of these leftover, these free CV. That CV is actually determines the structure, and that's because it's just so low. That's because these CVs are so low, and as these CVs are so low, you don't have a curvature here because you need two CVs in line in row. Don't forget we are working collinear here. So the only thing we actually need to do is just let me go to this history. Like having this history active, don't mess with the edges. They should be skewed because we already defined our directions. Don't mess with that. Instead, I will just pick this one CV. I will open up my CV manipulation tool, or as it's called. Actually, yeah, if you don't know where it is for some reason, it's this one. And it's called Transform CV Tool. Okay, Transform CV Tool. So this Transform CV Tool actually looks like this, which is the same as this. But in the later versions of Alias, for a lot of years actually, if you pick this tool, which I'm selected, and you will hit spacebar, it will open the new version of it. It's basically absolutely the same stuff, it just looks a little bit differently. Alright, so with the Transform CV activated, I will move that along the normals with the mouse sensitivity, which is kind of a little bit lower, not 1:1. And what I'm going to do is I will just starting to move. Well, actually, let me do this again. Evaluate and just move it. So as you can see, while I'm moving it, I'm moving it up, and this CVs, this second row of CVs moves up as well, which is exactly what we want. So, okay, you see, there was like a gap, I guess. Now that's already curvature. But we're not there yet, so we just proceed and just move it even further. Okay, now the curvature gone here. Let's move further. Alright, this one gone. Now we have an angle here. Let's try to move it up even more. Okay, now it's just rising. Alright, we don't want that to rise, so we'll leave it like this. And the only thing we need to fix after all of this is just this tangency of a 0.04 deviation. Very minimal. And as you can see, there is no marker for the curvature, which means that these CVs are already aligned properly. So the only thing we need to do is just to fix the tangency, at least I believe so. So to do that, I actually need to destroy my history, so I delete it. Otherwise, it will mess up with my CVs because it's under the history. And then, so there is an important thing. If you remember, I try to be collinear. So instead of moving it along the normals, I'll just move it up and down. So using this one, and I will just move it up. Oh no, actually move it down. Yeah. Even more. And yeah, here you go. That's it. That's curvature. Alright, so let me trim the surface now, because this surface is still intact. This leftover is still visible, so let me trim it like this. Now it's gone. And let me pick this, put it into the temporary folder, and let me check our finished piece with the zebra stripes. Wow, look at that. Perfect. Actually, this is exactly what I want. There is no discrepancies, it works great, and yeah, it's as natural as it can be on the forced surface. So basically what we did is we used the straight edges and still managed to build these patch with a really high precision and with a good flow. So that's how it does, how it done. Okay, so the model is not finished yet, but I probably finish the model in the next video. So yeah, I think that's it for this lesson. And in the next one, so we'll finish the cap. So basically finish all of it, right? And we actually kind of finished it, we need just to flip it across. So we'll finish the cap and we create the filleted walls, because in my example there is like a walls and there is a bottom part and they have a fillet across. It's actually, there is some tricks to really make this fillet the proper way, so it should be interesting. Yeah, okay, until then guys, goodbye.